We are going to look at a very basic introduction to air traffic management. This is a very large topic, and actually we can cover the details of this topic over the whole semester. There can be a separate course on only air traffic management spread over 12 weeks. But what we are going to do is, we are going to do this in two parts. The first part and the second part. In the first part, we cover some very basic concepts of air traffic management, and in part 2, we will go to slightly more difficult aspects. So, to start with, let us look at the first part of air traffic management. In this, I am going to cover objectives of the air traffic services. I am going to talk about the various ATS units that exist. I will talk about the three pillars of ATS: communication, navigation and surveillance. And then I will go and ahead with talking about the radars for the ATS systems and talk about rules of the air. After that, in part 2, we will look up at slightly more complicated topics. So, to start with, let us try to understand what are the objectives of the air traffic services. The objective is to prevent collisions. But collisions between whom? Collisions between two aircraft and collisions between aircraft and the obstruction or obstructions in the maneuvering area, including the vehicles moving on the ground, stationary objects on the ground, items which are required by function to be present at an airport. All of these should not come so close to the aircraft that it can have a possibility of collision. Once the air traffic controller or the ATS unit manages to prevent collisions, the next important objective is to maintain orderly flow of air traffic and to expedite air traffic. So, by expedite, we mean making it happen at a quicker or a faster pace. Another important objective of ATS is to issue advice and information for safety and efficiency. But this task they will be able to do only after they are able to do the main tasks of preventing collisions and then expediting and maintaining orderly flow. In case of any adverse situation, emergency or any incident, the air traffic unit also is supposed to notify and assist the appropriate organization in the search and rescue. So, to attain air traffic control, there are many different units or many different types of ATC. Here we look at the departure of an aircraft from one airport where there is a control tower to the other airport where there is also a control tower. So, the first control unit is called as the aerodrome control or the tower controller. This one is interested in only the movements in the airport and very much in the vicinity of the airport. Okay. The tower controller mostly works with visual aids. They also use various other aids, but they primarily sit in the control tower and visually look at the aircraft and talk to them on the communication channels and give them instructions. But their interest is only aircraft that are at the airport or near the airport. Once the aircraft leaves a particular airport, that means once takeoff is achieved, or when once the aircraft comes into land or goes for approach, there is a unit called as approach control unit. also called as a terminal controller, they are interested in controlling and managing the movements during arrival and departure. So I could say after takeoff and before landing. Takeoff and landing permissions are given by the tower controller, but once takeoff is achieved or once the aircraft comes in and touches down, the tower controller, their job starts. But when you are in the climb or when you are in the arrival, that time you are under the control of a terminal controller or the approach control unit. Once you clear the vicinity of the aerodrome and now go and attach yourself or fly along any of the routes, then you are under the purview of the en route controller, which is coming under what is called as area control. Area control does not have any visual link with the aircraft. It is solely and totally on the basis of radars and instruments. And then whenever there is movement of aircraft in the controlled airspace, then en route controller comes into play. After that, the en route controller will hand over to the terminal area controller as you approach for arrival at an aerodrome. Once you have already reached the final path and you are about to touch down, you will then be handed over to the tower controller, who will then guide you to the appropriate gate. There are several ATS units. Some are in the forefront and some are behind the scenes. So the aerodrome control tower, also called as TWR or tower controller, they are looking at the aircraft on the maneuvering area and in the vicinity of the airport. The approach control office, or APP in short, looks at arriving and departing aircraft, and the area control center, or ACC, looks at en route aircraft and the aircraft which are overflying a particular airport, who are not going to come in and land. So these are the ones which are in the forefront. But equally important, there are some units which are in the background. They are work behind the scenes. There is a Flight Information Center, or FIC, which is primarily required to give advice and information for the pilots. So before each departure, the pilots are supposed to go to the FIC and get briefing on the specific flight that they are going to take. So they go through the NOTAMs which have been issued. They get information regarding any malfunction of any unit. Basically, they get all the information that is required for safe conduct of the flight. They also get weather information at the destination and en route conditions. You have an ATS reporting office, or ARO, which is supposed to give you pre-flight clearances, and it does liaison with the defense agencies to ensure that there are no movements which are suspicious. At every major airport, you generally have an Air Force liaison unit. They are monitoring all the flights so that in the garb of commercial operations, there should not be any operations which are suspect. Technically speaking, the Air Force liaison unit is supposed to give clearance for every movement. And then you have the Aeronautical Information Service, or AIS, which is basically providing aeronautical information to all the people involved in the provision of air traffic services. There are three pillars of ATS on which the whole service stands. These are communication, navigation, and surveillance. What is communications? Communications basically is concerned with communication from air to ground, that is from the aircraft to the ground, communication between various air traffic positions in the same station, that is the inter-ATC position in the same station. There could be inter-ATC position communication between different stations or between different units. For example, there could be communication between two airports or the ATCOs in the two airports. Then there could be a dedicated unit for ATC communication for or during emergencies. And then we have the backup communication using the public switched transportation network or the conventional telephones that we use. So in case we have a scenario where the complete communication system of the ATC unit fails, the fallback option is the humble phone that you and me use for communication. Not the mobile phone, but the wired landline phone. Of course, ATCs also use mobile phone for communicating with their own peers and with other units if needed. And then there is ground to ground data communication. Here the communication takes place without any voice or verbal inputs. It is just data being transferred from ground to the ground. The next pillar is navigation. Navigation basically means the requirement of providing positional information to the pilot so that the pilot knows exactly where in the 3D space he or she is locating. This is important because earlier people used to use magnetic compasses for their navigation, which clearly is not sufficient in today's scenario. Then you also have to keep in mind that the navigation information that is required by the pilots to operate safely depends on the flight phase in which they are operating. In en route flying, there is also navigation. That communication takes place using either a non-directional beacon, automatic direction finder, or a very high frequency omni-range or VOR, or a distance measuring equipment DME. This is non-verbal communication where the pilot is going to tune the receiver to a particular frequency, which is the frequency at which any of these equipment are transmitting signals. This is used mainly during en route flying to confirm your location. Then you have oceanic airspace. In oceanic airspace, it is difficult to provide a large number of navigation equipment and also to regularly maintain and their upkeep. So you use the inertial navigation system and the global positioning system, right? Then you have approach and landing phase, which is near the airport. There generally the navigation is provided using an instrument landing system. We have a separate lecture on the instrument landing system and its functionality. Let us look at an example of navigation. So the first information is a flight plan. Flight plan is a document which is filed by the operating agency before each flight operation, and it contains a lot of information regarding the flight, such as which aircraft will be used through the aircraft identification, what kind of flight rules and type of flight is being operated, is it a charter flight or is it a regular flight, scheduled flight, are we operating under what are called as visual flight rules or under instrument flight rules, number and type of aircraft, and sometimes when you have formation flying or flying of aircraft in groups, you have to look at types of aircraft. Then based on the size of the aircraft, based on the weight of the aircraft actually, each of the aircraft is assigned a particular wake turbulence category. This is useful in ensuring minimum separation between two aircraft. I will talk about it in more detail. So that information has to be informed in the flight plan. What kind of equipment are working on the aircraft, what kind of equipment are required by function, the departure airport details, estimated off block time, that means at what time do you plan to operate, subject to clearance from the ATC, at what time you would like to start, what kind of cruising speed are you going to follow. If it is a multi-element cruise, then you will have various cruise speeds in various segments. For example, during cruise climb, so what are the cruising speeds that you plan and wish to operate? What is the destination airport and the total estimated elapsed time from the starting point to the destination? What are the alternate airport or alternate airports that you have in mind in case you cannot land at the destination airport? How much fuel are you carrying for what endurance? Total number of people on board that you expect to carry. This is especially true to plan the rescue missions in case there is any issue. Emergency and survival equipment which are present on the aircraft. Any other information that is relevant for the knowledge of the air traffic controllers to provide you the service. So here is a blank flight plan document, and all the points which I mentioned to you, mostly they are listed here. And here is an example of a filled international flight plan. So you can see, for example, here they are mentioning what is the route they are going to follow. These are all some points at which the aircraft is going to indicate the location. So it gives you the flight time, how many hours, minutes, seconds, what is the destination, what is the origin, what kind of aircraft registration number, what time of flight, all that information, which airport will you use, what time are you going to go, what kind of route you will follow. All information regarding this aircraft generally is provided. Okay. So this is a filled flight plan. Let us take an example of a flight that departs from VABB, that is the Chhatrapati Shivaji International Airport in Mumbai, and ends up in the New Delhi airport, that is VIDP. So here is the air route. Now if you notice, VABB is here the origin and VIDP is here the destination, and in between there are various points marked. We notice there are 11 points marked between VABB and VIDP. These 11 points are listed here. Some of them are fixes like Active, Bodar, Idola, Nikot, Gudum, Ribbon. These are fixes. Now what is meant by a fix? Fix is a theoretical location at which the pilot is supposed to report. Now these are not actual places on the ground. These are only points on the air route map decided based on the radials and the distances. And it is expected that when you pass over a fix, you can communicate with the ATC. If you are very much away as per the ATC's radar, you will get some information and then you can do some corrective action as a pilot. Okay. So the lat long position of each fix is specified. The distance from the previous point and also from the start is also specified, and there are names. So now some of these are NDBs, like there is a SG Songarh NDB. Then you have PRA, that is Pratapgarh VOR. Okay. It has got a DME also located with it. Most VORs nowadays have a DME associated with that. Then after 3 fixes you have the JJP or Jaipur VOR. Again you have a VOR DME there. After that there is one fix, and then you have DPN, which is the Delhi VOR plus DME, and the airport is VIDP. So you will notice when you see type here, you will see either airport or a fix or an NDB or a VOR. Okay. And this via basically is the route number. This is the route number. So if you look laterally on the side, this is how the flight profile will look like. The first point is the active, which is a fix. Okay. Then you have the non-directional beacon. At this point you are going to level. After that you will go through Pratapgarh, then Idola, Nikot, and then there are 2 fixes which are very near because this is the handoff point. After this you are going to be handed over to the Delhi area control. Okay. So you will be under the aerodrome control, and then you will be proceeding to the approach controller, then you will be going to the area controller. After area control you will be passed on to the other area control, that is the Delhi area control, and then you will be passed on to the Delhi approach controller, and finally to the New Delhi airport aerodrome controller. Now because this is a very busy route, therefore it's now there are one-way routes created. So between Mumbai and Bodar, which is the fix, we have, if we are going towards Delhi, you have a fix called Apano and then you go to Bodar. And if you are approaching from Mumbai, then you go from Bodar to the Songarh and then to Mumbai. Similarly, after Pratapgarh, if you are proceeding to Delhi, you will go straight up to Jaipur and then you will go towards VIDP. But when you are proceeding from Delhi towards Mumbai, you will not take the same radial. You will go via this radial where you will be reporting to a point called Dipas and then Asovo and Bidan, and then you come to the Pratapgarh, right? Pratapgarh VOR DME. So one-way routes have been created to avoid congestion. And this line indicates the handover line. Okay. So you are handed over to the Delhi area controller at the fixed point called Idola. And finally, we look at surveillance, the third pillar. Surveillance basically keeps in mind what information does the air traffic manager need to provide the services. What they need is basically a consolidated real-time picture of all the air traffic in the airspace defined for a position. So the area controller will be interested in getting a picture of the real-time movement of all the aircraft which are within their jurisdiction. Even in area control, there can be many multiple sub jurisdictions at busy airports. Okay, whatever it is, every position has a jurisdiction, and the ATCO there would like to have a real-time picture of the traffic situation so that they can take decisions. How is this information provided today? It is provided using various types of radars. Okay, so there are primarily 4 types of radars. There is an Airport Surface Reduction Equipment, or ASDE, which is installed at some airports, not every airport, especially those airports which have a very large amount of ground movement of aircraft and vehicles and other support systems. So there the congestion is too much, so therefore you need a dedicated equipment for detecting the Air Force surface movement. Then you have the ASR, okay. Then you have ARSR and then you have MSSR. We will look at all these radars one by one. The radar for aerodrome controller is ASDE, Airport Surface Reduction Equipment. As I said, this will be useful for determining the movement of aircraft, vehicular traffic and personnel at the airport. All of them will be monitored. This is an example of an ASDE equipment. Primarily, it is helping the ATC to know if there are any objects near to the aircraft, and also it will warn if they are coming in the close proximity, so that you can be given instruction. So as I said, ASD is not in every airport, it is only at those busy airports where there is a large amount of surface movement. You generally have an airport surveillance radar, or ASR, for the approach controller. Here you are able to monitor the air traffic only within 60 nautical miles of the airport, around 120 kilometers from the airport, approximately, less than 120 kilometers. Why? Because approach controller is only concerned with the aircraft which are in the final approach or they have just departed from an airport, right? So we have primary and secondary radars. Okay. Here is a picture of the airport surveillance radar. Then you have a radar for area controller. Area control has a different responsibility compared to the approach controller. They use air route surveillance radar. These are having much higher range. When earlier the ASR was having a range of only 16 nautical miles, the ARSR generally have a range of around 220 nautical miles. This particular structure you will see near Mumbai at the Juhu Aerodrome. So the ARSR of Mumbai Airport is actually stationed at Juhu Aerodrome. Then you have secondary surveillance radar, or SSRs. The ARSR detects only the bearing. That means it will just tell you in which direction the aircraft is. It does not give you anything more than just the presence and measurement of the location of the aircraft. Okay, and this is done by using the reflections of the signals on the radar. SSRs request additional information from the aircraft apart from the distance and the bearing, or apart from the location and the distance. It also gets to know the identity of the aircraft through the flag of the aircraft, and it uses replies to an interrogation signal by an onboard transmitter. So, some of the signals are standard, so you can program against it with your own onboard transponder. So, what you do in SSR is that you send a signal which goes to the onboard transponder of the aircraft. The transponder then replies, and with that reply you are able to identify the aircraft and also the altitude. Altitude is important because ARSR only gives you the bearing, it does not give you the altitude. This is the more positive detection of bearings. Okay. After 1990s, most of the SSRs were replaced by MSSRs, which are basically monopulse secondary surveillance radars, because they avoid two problems which were very prominent with the SSRs. They are called as garbling and fruit. These are terms which relate to the avionics or the behavior of the displays. So, fruit basically is something like a small banana type area which will continuously get reflected from signals, and it will give a approximate indication of the aircraft, not exact indication. Because of the MSSRs, we got more precise and accurate information to the ATCOs, and therefore, in the en route airspace, the separation minima was reduced from 10 nautical miles to 5 nautical miles, because now more precise location of the aircraft is available through MSSRs as against the SSRs. Let us have a look at the rules of the airs, or the rules within which operations take place in flight operations take place. The rules depend upon the meteorological conditions called as the VMC, or the visual meteorological conditions. These are limiting conditions in the terms of visibility, that is how much can be seen, and the distance from the cloud and the ceiling of the clouds. So, there are certain norms which are provided, and if those norms, for example, if the visibility is below a particular number, if the distance from cloud is a particular value, or if the ceiling is lower, then it could be said that flights cannot take place under the visual rules. If the conditions are very good, if there is very good visibility and the clouds are very far away and the ceiling is also very high, then we can operate under what is called as visual flight rules, or VFR. In operations in VFR, the pilot is responsible to maintain the visual meteorological conditions and to maintain the separations. Okay. But if you operate under the instrument flight rules, or IFR, then the pilot need not conform to VMC, because the responsibility of the separation is then shifted from the pilot to the air traffic controller. The pilot is supposed to rely on the instruction given by the air traffic controller. Normally, the IFR rules are applicable when you are in very controlled airspace, as I will talk to you later, or when the weather conditions are very bad. There is a special VFR also, which is nighttime VFR, which is generally applicable for the helicopter pilots. Let us look at how the airspace is classified. There are 4 FIRs under India's jurisdiction. FIR stands for Flight Information Region. These 4 FIRs are as follows. There is the Delhi FIR, then you have the largest of the 4, which is Mumbai FIR, Chennai FIR and Kolkata FIR. Now, the Delhi FIR, as you can say, is completely on land. All the area of the Delhi FIR comes under land, there is no oceanic airspace. Mumbai, on the other hand, has a very large area over the ocean. So, our FIR ranges down up to Mauritius. So, Mauritius has another FIR, Similarly, Chennai covers a large land area but also a lot of oceanic airspace, and then Kolkata also covers roughly half. So, if you look at the jurisdiction of the 4 FIRs, Delhi VIDF, name of the FIR, it has a 10.2 into 10 power 5 square kilometers of area which is continental, zero oceanic area. If you look at Mumbai, which is codenamed as VABF, the Mumbai FIR, you have almost the same area of continental, but you have 3 times more, 37 lakh square kilometers of oceanic airspace. So, the total airspace of Mumbai FIR is 4 times that of Delhi, which is 47.1, more than 4 times. You have Chennai VFR, which is VOMF, that has got a large continental area of 14.3 lakh square kilometers. The oceanic airspace area is 10.5, so the total is 24.7 square kilometers. And then you have the Kolkata FIR, which is VECF. This also has large land area or continental area, little bit of oceanic airspace, total of 18.5. So, by area, the Mumbai FIR is the largest, followed by Chennai, followed by Kolkata, and the last of them is Delhi. There are several challenges in providing the navigation service in the FIRs under India's sovereignty, and it is important for us to have a look at those challenges. More than half the airspace controlled by the 4 FIRs in India is under oceanic airspace. And in the oceanic airspace, there is a problem that we do not have very reliable navigation systems. Okay. Substantial airspace within the 4 FIRs is not available for commercial or civil aviation. This is because there are many areas which are not available due to defense, or there are no fly zones. Most of the area in northeast is very difficult and inhospitable because of the climatic and the geographical conditions. There is inadequate and unreliable support infrastructure at many places except the metros and tier 1 cities. You will see that as you go down to tier 2, tier 3 cities, the infrastructure becomes unreliable and inadequate. There are power supply and communications issues. Then there are also issues of internet connectivity. You have insufficient ground-based navigation equipment in the country because the performance of these depend on terrain conditions. Therefore, not one can be picked up and taken somewhere else, and you need to have it to be tuned for a particular domain. Then these equipment are very expensive to maintain and they require periodic calibration. So, they are in the middle of nowhere, very expensive to maintain and require calibration every once in a while, but the performance is dependent on the terrain conditions. Let us see the types of airspace. You have controlled airspace, where the area or that airspace is regulated and controlled by ATC services, and inside that there are certain areas which are prohibited or restricted or military use only or special use only or warning and others. Okay. Or you can also operate under uncontrolled airspace, where there is no authority or control by ATC authorities. The pilots are required to take care of the separation and to maintain the VFR minima. Okay. So, when you look at categories of the airspace, you can go from A to F. A to F are controlled and G is uncontrolled. So, you go from A to G actually, and from A to F you are slowly going into more and more relaxed. So, A is the most controlled, F is the least controlled, but they are both in controlled airspace. Uncontrolled airspace is classified as G. This picture shows the various types of airspaces that you can encounter near the airport. So, you can see, for example, this class A airspace is flight level 6000 or 18,000 meters mean sea level, above mean sea level. This area is called as no fly zone in a way, or it is class A airspace, which is completely controlled. Then you have class E airspace, which is shown in this blue color. Then you have class D airspace, class that is shown here. You have class B airship, class C and other classes also. Class G airspace is the airspace which is called as unrestricted airspace. So, where is it unrestricted? Up to 400 feet above ground level, you can fly an aircraft, quadcopter or any aircraft of your choice without getting penalized for any air-to-air collision with any other aircraft. But above that, you also will be injured. So, let us look at these classifications. As you increase the ladder from A to G, you are relinquishing the control and you are passing the responsibility to the pilots. In G, the complete responsibility of the pilots. In A, the complete responsibility of the ATC. In class A, this is applicable to only IFR flights. Okay. So, class A airspace, all flights are given information, only IFR operations are permitted, but all the flights are subjected to ATC and all the flights are separated from each other by the positive action of the ATC. In class B, you have the same rules as class A, but the flights could be IFR or VFR. In class A only IFR, in class B you can have IFR and VFR flights, okay, but all the flights are separated from each other. Class C is same as class B, but separation is maintained only for a few class of aircraft, between two IFR aircraft, between IFR and VFR aircraft, okay, but not between VFR to VFR aircraft.